student of class 9. In the previous physics class, we know there about the concept of linear momentum. Newton gives his second law of motion, which is totally depends on the concept of linear momentum. According to Newton's second law of motion, the rate of change in linear momentum of a body is directly proportional to the external force applied on the body, and the change in momentum of the body takes place along the direction of applied force. As we know from the Newton's first law of motion, the inertia property and the definition of force, from the Newton's second law of motion we know about the measurement of force, means how much external force is acting on a moving body we can calculate using the second law of motion. How it is possible to measure the amount of force acting on a body? We have to know the equation for the measurement of force. Okay, now we want to derive that equation. See the calculations. Let mass of an object is small m. This object moving with initial velocity u. After some time t, the velocity of the object becomes v, where v greater than u. So as the final velocity of the object is greater than the initial velocity, therefore we can say this object moving with an acceleration. Okay, now to change the velocity of the object from u to v, we are applying an external force on the object, say capital F. Now to apply the Newton's second law of motion in this situation, we have to calculate the rate of change in linear momentum of this moving object. So therefore rate of change in linear momentum equal change in momentum by time taken. What is the change in momentum? Final momentum minus initial momentum. What is final momentum? mv minus what is initial momentum? mu. And whenever this change in momentum divided by time taken, we get the rate of change in linear momentum. According to Newton's second law, the external applied force F is proportional to the rate of change in linear momentum, that is F proportional mv minus mu by t, or F proportional, we can take m common from here, so therefore m into within bracket v minus u by t, and this v minus u by t is known as acceleration of the object. So therefore F proportional ma. Whenever we omit this proportionality, there will be a proportionality constant k. So therefore F equal kma. If this k equal 1, then F equal ma. By this equation, we can measure the external force acting on a moving object. So therefore external force F equal mass into the acceleration of the object. Whenever you want to measure the amount of force, you have to know the unit of force. Now see, unit of force. There are two types of unit available for the force. Number one, absolute unit, another one, gravitational unit. In absolute unit system, the SI unit of the force is Newton and the CGS unit of the force is dyne. In gravitational unit system, the SI unit of the force is kilogram weight, or you can write kgf, and the CGS unit of the force is gram weight, or you can write gram. You have to know the definition of the unit of force. First one, Newton. Okay, so you can write from the equation of force, 1 Newton is equal 1 kg into 1 meter per second square. See, 1 Newton equal 1 kg into 1 meter per second square. From this mathematical expression, you can define 1 Newton of force. How? 1 Newton of force is said to be act on a body of mass 1 kg which is moving with an acceleration of 1 meter per second square. Similarly, we can write 1 dyne equal 1 gram into 1 semi per second square. So, what is the definition of 1 dyne of force? 1 dyne of force is said to act on a body of mass 1 gram whenever the body moves with an acceleration of 1 semi per second square. Now, what is the definition of 1 kilogram weight? Which we can write 1 kilogram weight is equal 1 kilogram into 9.8 meter per second square. So therefore, we can say 1 kilogram weight of force acting on a body of mass 1 kg whenever the body is moving with an acceleration of 9.8 meter per second square. Now you have to know the definition of 1 gram weight, which is equal 1 gram into 980 semi per second square. 1 gram weight of force is said to act on a body whenever act on a body of mass 1 gram which is moving with an acceleration 980 semi per second square. Now, for solving the numericals using the second law of motion, you have to know the relation between the gravitational unit and the absolute unit of force. Now, 1 kilogram weight, which is the SI gravitational unit of force, is equal 9.8 Newton, and Newton is the SI absolute unit of force. So how can you convert from the gravitational unit to absolute unit? To convert the gravitational unit to absolute unit, you have to multiply the gravitational unit by the value of small g, that is the accelerations due to gravity. That's why 1 kilogram weight is equal 9.8 Newton, because SI value of small g is 9.8. Similarly, 1 gram weight is equal 980 dyne. As in CGS system, the value of small g is 980. Now, using the Newton's first law and depending on the property of inertia, there we explain the various phenomena which are occurred in our surroundings. Similarly, using the Newton's second law, also we can explain the various phenomena which are occurred in our surroundings. Number 1, taking a catch. Whenever a cricket player taking a catch, then the cricket player lower his hand. Why the cricket player lower his hand? We can explain by the concept of Newton's second law. According to Newton's second law, force is equal change in momentum by time taken. Catching of ball means the momentum of the ball reduces to 0. If the cricket player during the catching of ball fixed his hand, then the change in momentum takes place in a very short time, for which the force exerted on the hand of cricket player is very high. But whenever the cricket player lower his hand, then the change in momentum of the ball takes place comparatively in a more time. That's why the force acting on the hand of the cricket player is less. That's why during the catching of cricket ball, the player lower his hand. Number 2, breaking a pile of bricks in a single blow. Now during the show, the showman can break a pile of bricks in a single blow. Now, whenever the showman gives a blow, the momentum of the hand of the showman changes in a very short interval of time. And from this equation, whenever the time interval is very short, the force which is created by the showman on the piles of brick are very large, and by this large amount of force, the showman are able to break the pile of bricks. Similarly, in the same way, you can explain the jumping on cemented floor is more dangerous than the jumping on sand floor, because whenever a man jumping on cemented floor, the change in momentum of the man takes place in a very short time, which will create more force on the man. But whenever the man jumping on sand floor, then there will be a chance of yielding the sand, for which the change in momentum occurs in a large time, for which force acting on the man is very less. That's why we can say jumping on cemented floor is more dangerous than the jumping on sand floor. Now student, I want to give a totally new concept to you, which is known as impulse. Impulse is denoted by generally I, which is a vector quantity. That's why I put an arrow over the letter I. So what do you mean by impulsive force actually? Whenever a huge amount of force acting on an object for a short time, then the force is said to be impulsive force. For example, kicking a football, hitting a cricket ball by bat, striking an iron nail by hammer, in all of this situation we are applying an impulsive force. So how can you measure the impulsive force? Now see the equation. Impulse is equal force into time duration. So therefore I equal F into T. So as I equal F into T, so therefore SI unit of impulse becomes Newton second and CGS unit of impulse become dyne second. By this equation we can measure the impulsive force acting on an object. There is another equation by which we can measure the impulse acting on an object. Okay, just see, impulse is equal change in momentum of the body. Impulse is equal change in momentum of the body. So therefore, if you are able to know the change in momentum of a body, you can say the impulse acting on the body. Okay, now there are certain types of graphical problem depending on this impulse concept may asked in your question paper. Now see, this is a force time graph. Okay, now from the force time graph we can determine the impulse acting on the object. Now from this graph my question is determine the impulse acting on the object between the time t1 and t2. Okay, so remember from the force time graph we can calculate the impulse by calculating the area covered by the force graph with time axis between the two given interval of time. So therefore between t1 and t2 the impulse is equal the area of this shaded region. That's why I write impulse is equal area covered by the graph with time axis between t1 and t2. Thank you student. All this portion read very carefully. If you face any problem, you can contact with me. Thank you.